So today we're going to learn about factoring quadratics using the area model. In order to do that, we first need to know how to use an area model in relation with quadratics. So I'm going to start with this first example here, where it says to multiply these two binomials together, 2x minus 3 times 3x plus 2. So let's go ahead and look at what we can do here. Technically, we have an area of a rectangle is length times width. Well, we have two dimensions in our multiplication above, so we can let the 2x minus 3 represent the length and 3x plus 2 be the width. Let's go ahead and put that on our rectangle. It doesn't matter which one goes on which side, but we need a 2x minus 3, and then we need a 3x plus 2. Because it's a positive 2, you can just leave it as 2. Now we're going to go ahead. The area of this entire rectangle can be found by multiplying the length times the width. Technically, though, we can also find the area of the rectangle by finding the area of these 4 individual rectangles and then add them together. So we're going to go ahead and do that. In our first rectangle, 3x times 2x gives me 6x squared. Going across, 2x times 2 gives me 4x. Negative 3 times 3x gives me negative 9x. And then lastly, negative 3 by 2 gives me negative 6. Notice when you're doing the area model, the diagonals will always be like terms. So this one, negative 9x and 4x are our like terms. So we can combine those. In fact, if we combine all 4 of these together, we are going to get that 2x minus 3 times 3x plus 2 is 6x squared. Negative 9x plus 4x is a negative 5x. And then minus 6. So now, if we want to factor, we want to be able to go the opposite way. So we want to be able to start with this trinomial and put it into 2 sets of binomials. Basically, we want to break it into what is the length, what is the width of our rectangle. Let's go ahead and look at an example. Here we have x squared minus 7x minus 18. Think back to the example we just did. In the example we just did, we knew that the top left corner was the x squared term. The bottom right corner was the constant term, the term without any variables. And then we knew that these two together in this diagonal added to be that middle term, negative 7x. So let's think about this here. We need 2 numbers that multiply to give us this negative 18 here, here, and here, but they need to add to be negative 7x. I'm going to go ahead and list all possible numbers that go to negative 18. So for negative 18, we need the bigger one to be negative if it needs to be negative 7x. So we could have 1 and negative 18. We could have 2 and negative 9. Or we could have 3 and negative 6. This one here, 2 and negative 9, is going to be the one that adds to negative 7x. Therefore, we want to put a 2x in one of the boxes. It doesn't matter which one. And the negative 9x in the other. And double check, 2x plus negative 9x gives me the negative 7x. Great job. Now we need to work backward to figure out the numbers that would be the length and width of our rectangle. Working backward, x squared, there's only 2 values that can multiply to be x squared. We need an x by x. In fact, this will always be the case when our coefficient here is 1. Now, if we keep going, let's look at what would be missing here. So if we have a negative 9x here, and we knew that the height of it was x, this has to be negative 9. Similarly, down below, if this one was 2x, and we knew that the width of it was x, this has to be 2. And then just double check, 2 by negative 9 does give me negative 18. Nice job. So this means that our final answer, x squared minus 7x minus 18, would then factor to the length times width of our rectangle, which we have an x minus 9 and then an x plus 2. You can see those on the outsides of our rectangle. Unfortunately, things are going to get difficult though when the leading coefficient, the coefficient in front of our x squared term, isn't 1. So we're going to go ahead and look at an example of that. Now this one here is a great example because not only is the leading coefficient greater than 1, but also it's one where we can take out a greatest common factor before we even begin. Notice all three of these terms have a b in common. So we want to make sure that we're always checking and taking out a greatest common factor if possible. So this one, if we take a b out, we're left with 3b squared minus 5b plus 2. Again, always double check if you can take out a GCF and do it if possible. Otherwise, it's going to mess this method up. Okay, so now we're looking at this quadratic. 3b squared minus 5b plus 2. That's what we want to factor. We want to figure out what can we do in our area model to get that. So we know that the squared term, 3b squared in this case, is going to go in the top left box. We know that the constant term, positive 2, is going to go in the bottom right box. And then we know that the other two diagonals together have to add to be negative 5b. Now, this one is different. We actually use a method called the AC method. Where it comes from is because a quadratic is usually ax squared plus bx plus c. So a times c is the AC method. In our case, we have 3 times 2, which is 6. Now, when we're using the area model and factoring using the area model, we need two numbers that multiply to be our AC, which in our case is 6, but add to still be this negative 5. So let's go ahead and see what numbers we can find. Because we have a positive number for AC, yet a negative number when we add our things together, we know that both numbers are going to have to be negative. For example, negative 1 and negative 6 would multiply to be positive 6, but they could potentially add to be negative 5. Unfortunately, they don't, so we need to keep going. Negative 2 and negative 3 is our other option. Negative 2 times negative 3 does indeed equal positive 6, and when we add it together, it does equal negative 5b. So that's what we get to fill in our boxes with. Again, doesn't matter which one, but a negative 2b goes in one of the boxes, and a negative 3b goes in the other. Now we need to look at the different rows and columns and find the GCF of each. So let's go ahead and do the columns first. This first column, 3b squared and negative 2b, what do they have in common? They both have a b. Moving on to the next column, we have negative 3b and positive 2. These technically have nothing in common, but every number has a 1 in it. One other thing to keep straight would be where the negatives are. If the negative is in the box closest to the one that you would be taking the factor out of, take the negative out with it. So this would actually be a negative 1. Okay, now moving on to the rows. Our top row, we have a 3b squared and a negative 3b, so those have a 3b in common. And then our bottom row has a negative 2b and 2. Again, though, because that negative is in the box closest to the one we're taking out, we need to take the negative out with it. So it would be a negative 2. Therefore, we can factor, again, don't lose the b that we originally took out, but we can factor the remaining quadratic. In fact, it becomes 3b minus 2 for one of our factors, and then b minus 1. So that would be your final answer.